Alright, in this last video for Unit 8, we are going to be identifying zeros and sketching graphs of any kind of random different function. So we're going back to our graphing calculator. So make sure you have that out at this point. If you don't, pause, grab your graphing calculator, and come on back. Alright, so here's the directions. These are the directions that you guys are going to see when you are getting your quiz and your test. Solve by graphing. For each problem, sketch the graph, find and label the coordinates of all points that represent solutions. Remember, solutions and zeros are the exact same thing. Write your solutions, rounded to the nearest hundredth. That's 2 decimal places. So again, quick rounding review. If it was 0.137, that would round to 0.14 because the third decimal place tells you what to do with the second. If it was 0.132, that would stay as 0.13. The 2 tells me to keep the 3 the same. Anything 5, 6, 7, 8, or 9 would tell me to bump that number in front up. And when we write our solutions, this time it's not ordered pairs. We're actually going to write x equals whatever our solutions are, whatever the x coordinate is of that 0. So, without further ado, let's take a look at the first example. I'm going to go through the graphing calculator part fairly quickly. We've done this stuff quite a bit throughout the year. As you're in y equals, you must put your fraction in parentheses. So make sure you always do that. X squared plus x minus 4. But go back to Unit 1 or Semester 1 too. Equals 0 means I'm going to put the left side into y1 and the right side into y2. So the right side of this equation is 0. When I hit graph, it should be centered here. If it's not centered, if my graph isn't centered, then you do zoom standard. So zoom standard is 6, and it will automatically center the graph for you. We can see in my diagram we have the blue curve and then the red line. My solutions are the intersections. So just like first semester, it's second trace 5 because that's intersect. Now, remember earlier in the chapter we talked about this. To get my solutions when there's more than one, I have to scroll close to the intersection before I hit enter 3 times. This is at 2, 0. Now, I am going to sketch this graph before I actually write my solutions. So I have my curve, but what we want to pay attention to is where are these zeros? We just saw this one's at 2, 0. So over here I'm going to mark on my graph something about 2, 0. My other one is -1, 2, 3, about -4. We'll see if it's exactly -4, but I'm going to mark that over here. Next, I also recognize that I have a minimum on that curve, and that minimum is in quadrant 3, but just barely. So I'm going to go into quadrant 3, but just barely, and plot a minimum. In this particular problem, they don't ask us to find that. What they do ask us to do is sketch this graph. So here's where I can take and sketch my curve. Now, there's nothing perfect about what I just did, but it's close enough. You just need it to be a curve. Don't draw lines. Okay? And then your second part here was your x-axis. So you can graph that this way. We just calculated this point to be 2, 0, so our answer would be x equals 2. Now we need to find my second intersection point, second trace 5, and I am going to scroll to the left. And again, if I skip pressing up, I can skip to the red line as opposed to being on the curve, and that kind of is a shortcut way of getting over closer to my second intersection. Once I'm there, enter, 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 I'm at -4, 0. So this ordered pair is at -4, 0. My second solution is x equals -4, and we're done. For the second example, it's a little bit different because it's not equal to 0, but we're going to wind up with the same thing. Go ahead, press pause, type these into your calculator, and try to sketch a graph. So our equations should look like this. We have y1 in, make sure it looks this way, y2, make sure you have parentheses around your fraction. And when we hit graph, it's a little different. We have a curve, but then we don't have a horizontal line because 1/2 x plus 3 is this red line. So when I go to sketch this, I'm going to look and I see that my curve has x-intercepts just barely past the origin and a little further with a minimum. So maybe here, here with a minimum. That allows me to graph this curve. And then the next thing I have is this line. This is the 1/2 x plus 3. It crosses the x-axis kind of halfway through my negatives. And then I cross the curve, then the y-axis, and then my curve again. So I look at it as something like this. There's my graph. Now, solutions. Solutions aren't x-intercepts here. Solutions are this ordered pair and this ordered pair, where the lines cross the x-axis. So, just like before, it's second trace 5. I'm close to an intersection, so I hit enter, enter, enter. The intersection is at negative 0.5, 2.75. Which means this first solution is x equals negative 0.5. Second solution, second trace 5. Scroll closer to the second intersection. If you don't scroll closer, you will not find the new intersection point. Get closer, and we hit enter 3 times. 4, 5. So, x equals 4. I need a new x equals for every different intersection. For every different solution, I need a new x equals. Very different one. Go ahead and put this in your graphing calculator. So if your graph looks like this, you got it right. At this point, we have this red portion. That's what happens. This red is one graph. It looks like 2, it's 1. That's what happens when you have x in the denominator of your fraction. So let's go ahead and get this sketched. Okay, so when we sketch this graph and find our intersections, again, scroll close. It's important that when you start this, you scroll close to your intersection, second trace 5, enter, 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 and then close to your second intersection. After you do second trace 5, scroll close, enter, enter, enter. We get our intersections at negative 1, negative 3, and at 3, 1. Our solutions are x equals negative 1 and x equals 3. Now let's spend a little bit of time on our last one because this one's quite different, but this is exactly how it'll appear on your tests and your quizzes. I will give you this information. It's really important information that you follow up on. So, first thing when I'm in my graphing calculator, I need to put my calculator in radian mode. That means I press this mode button here next to second. If you look at our options, we have fourth down, radian or degree. Mine's in radian mode right now because that's highlighted. If yours is highlighted over with degree mode, like this, you need to scroll up to radian, so it's blinking on radian, and hit enter. That changes it to radian mode. Okay. Now I need us to set our y max, y min, x min, and x max. That's in the window, so you press the window button. It's telling us to use, so I need to do this stuff first. Okay. My x min should be 0, so I'm telling you where to set these. X min 0, x max 6. My y min negative 5, my y max positive 5. So scroll down to y minimum, negative 5, y maximum, positive 5. Everything else can stay the same. Now I can go to my y equals. And I'm going to clear out what's here. And y1 is going to become 2. Sine 3x. The sine, cosine, and tangent buttons are these 3 buttons here. These are the 3 buttons we're going to be using in these weird, different looking functions. So 2 sine, it automatically opens parentheses for me. I type my 3x in those, then I close those parentheses. That's what this function's telling me to do. Subtract 1. Scroll down, my y2 becomes -2. So this part's all exactly the same. Type in what you see as y1 and y2. Hit graph. This is a sine function. This is what a sine function looks like. A trig function is going to look like. It's this curve. I've focused this window so that I'm only looking 5 up, 5 down. I'm not looking left at all, and we're only looking 6 to the right. If we looked at this in our standard window, it would just continue to curve up and down and up and down and up and down the entire way. That's what a sine curve does. Okay. What I do from here, other than sketch this, and so here's how I sketch this, I see that it starts a little bit below my x-axis. So I'll put my starting point on here a little bit below the x-axis, and then you identify how many minimums and maximums. I have one minimum, or one maximum here, another maximum, another maximum. So 3 maximums, 3 minimums before I get to the end. So I'm going to have a maximum, and it's just a barely above, minimum, maximum, minimum, maximum, minimum. And then you can go ahead and sketch that curve. It's just curving up and down, and you can stop. Now we're not going to put an arrow there, we're just going to kind of stop it there, mainly because it doesn't continue going down forever. This is a trig function. It would actually at this point curve back up. So we're not going to put an arrow on the end. And then we didn't get the curve going back up here, and that's where it stopped. And then we have our red line, my y equals -2, going horizontally across. Like that. And I actually have now 1, 2, 3, 4, 5 separate solutions to find. And that's a matter of doing second trace 5. I like to jump right to my horizontal line. That's the easier one to follow. And I'll just start at the left and work my way from left to right, finding my intersections. And so I continue scrolling as far left as this first intersection. I get close to it, and I hit enter 3 times. 1.221. The 1 tells me to keep the 2 the same. So this intersection is at 1.22, comma -2. First solution, x equals 1.22. Go ahead and take the time right now. Find all 4 of the other intersections and write your other 4 solutions. When you're done, unpause it. So because there are 5 intersections, there are 5 solutions. If you don't give all 5 solutions, you will not get full credit. There's definitely a quiz question with a trig function like this, and definitely a test question with a trig function like this as well. We'll spend a lot of class time reviewing how to do this.